Okay, so let's go ahead and get started. Administrative stuff first. Obviously, the exam was last week, and then we had a break, so we haven't met in about a week. This exam, I did get feedback from students, seemed to be a bit harder, and there are some things with the grading scale that I kind of want to work out for the final, so hopefully that'll be a little bit more fine-tuned next time, but I did curve at least accordingly to try and fix any issues. So the average was 68%, and I curved it up by 8%, so it's above a C, or it's about a C, I guess. So make sure, I know I already put an announcement on Canvas, but make sure you got 8 fudge points at the bottom. So I gave everybody an 8% curve, and if you had the questions OU2, I'll erase it in a second, but OU2 and RM6, which I think only 2 people actually got these questions, so I guess it's not a big deal. Then let me know, because I think one of them we didn't go over and the other one had a typo, so I gave back points on those ones. That being said, I do want to go over. So I'm going to erase these so I can write. They are on Canvas though, so you can always go back and look at that. There's an announcement. I wanted to go over 2 questions that I think most students missed, and then go over any questions that anybody may have as well, if anybody wanted to ask anything. Right, so let's go over those 2, and then I have a couple other notes that I want to do. So these 2 questions kind of go together. One was what is tail recursion and what is head recursion, and I got a lot of answers that were on the right track at least, but maybe didn't phrase it the right way. And I think that was one of the comments I had here in general, was just some of the phrasing was a little bit off sometimes, and I understand that sometimes it's hard to keep track of all the terminology because there is a lot. So I try to be generous with those. I try to give back points, even if you don't necessarily use the right term, but just as a general tip for just going forward with classes like these, try to keep your answers super succinct. Don't over explain anything. Don't write too much, because the more you write, the more likely you are to put something down that might be wrong or contradict what you've written before. And that happened with a lot of students. I think when I was grading, if you put the right answer and then later put something that was wrong but was unrelated, I still gave you points. But if you put something that contradicts what you put earlier, then I would have to take off points. So just don't over explain it. Don't try to use too much jargon. You can keep it super simple. There are a lot of cases where I think students use terms that meant other things than they thought, which is totally okay. We learn them over time, but just be careful with that. And I think this was one of the big questions where that was an example of that. So head recursion and tail recursion. The definition, I guess, is a little ambiguous, but I got a lot of things about it being the first line in a function as responses, and just know that's not necessarily the case, and it can't ever be the case when we're doing recursion. Because if you have something that does recursion as the first statement, and that was specifically the answer to this one, I got a lot, then consider that if you do recursion as like the first line of your thing, if I had a function called, like, let's just say void foo, and the first line was foo, and then, did some sort of reduction or whatever. These don't take parameters, but we can assume there'd be something that does. Then this will never have a chance to check any base cases before it gets to a recursive call, which means this is going to Stack Overflow and never work. And so I'm not sure if this was what a lot of people intended when they gave this answer, but that's kind of what I took it as. And I know it's kind of hard to explain, but yeah, not necessarily the first statement in a function, but it's the first part of either a set of statements, being the recursive part of your code, or it has to do with expressions. And I think expressions was probably the answer I was looking for on that one. So for example, if I was doing addition, let's say that this was an integer returning function, then I might do something like this for return, let's put ret for short, so it fits ret 4 plus foo. Then this would be an example of tail recursion. And then if it was vice versa, like foo plus 4, if the recursive call is the first part of an expression, then that's head recursion. So just so we're all on the same page, it's the first part of either a set of statements or I would say expression is probably the word that you're looking for. And by expression, I just mean something where an operation is done and it returns a value, or simplifies down to a value like plus, minus, times, divide, that kind of stuff. So that one, I think the terminology was the issue, but I think everybody at least had kind of an idea on it, so I usually gave partial credit on that one. And then the other question I wanted to go over, which I think most people missed, was this one. I don't think we covered this in detail in lecture, but when we're doing virtual functions, or really just any kind of function where we have inheritance of classes, then you can allow accessibility kind of like how you would with a getter and setter. So remember that getter and setter, mutator and accessor, those exist so that you can limit how people interact with your variables. So if you had a private variable, if you only made a function that gets that variable and made that public, then people can only get that variable outside of the class and they can never set it, which is kind of common behavior, right? You can limit one of the two accessors, getting and setting, and make that the only one that's public. In the same sort of way, you can make functions that are private indirectly callable by making other functions that call them public. In this example, we have a class called GameObject that has a private function called render, and then a public function called update. And then we had a class that inherits from it called player, and it had its own function called update that overrides this one. So it was virtual. We could override it, so it's going to redefine the behavior, right? And the question here was, how do we get this to call the render function via the player update function? And the two responses I got that were really common on this one was, A, that's impossible, which I suppose maybe the phrasing was a little ambiguous on that. So it is possible. And then the second one I got was just calling the render function normally. I think were the two most common responses I got to this one. And we can't do that because it's private and we're in an inherited class. So that's a no-no. So instead, what we can do is we can call it indirectly. Consider that this public function update in the GameObject class, that allows you to indirectly call a private function, and that's kind of similar to just exposing things indirectly or not completely, like with that getting and setting stuff. So what we want to do here in this example is we want to call the GameObject update function, and the way we have to differentiate that, because we're doing inheritance, rather than call this update function, so I can't just do update. That's not going to work because that's going to recursively call itself, because it knows that that's the current class it's in. Is instead we have to specify that it comes from the GameObject class when we call it, and so it would be GameObject update. Does that kind of make sense, or any questions on that one? Okay, fair enough. Before we continue any further, did anybody have any other questions that they want to go through on the exam, or any questions that they had on assignment 7, which got pushed back to tonight? Actually, I forgot to mention. So assignment 7 got pushed back, or sorry, not 7, 8. Assignment 8 got pushed back to tonight, and then the extra credit assignment over the weekend, I went and finished the video and the code grade stuff, so that's up if you want to work on that. But did anybody have questions on either of those two things, the exam or assignment 8, that you wanted to cover? So can we do an overview of the do they meet function? Yeah, we can definitely do that. So I think I should probably open up the PDF just so I remember exactly what arguments it takes. So here's the assignment 8 PDF. We'll see the do they meet, which I think was a forest function. We had a forest function called do they meet, and it only takes an integer, right? So because it's in the forest class, it's going to have access to all of these members, specifically obj1 and obj2, which are pointers to the objects that are moving, whether that be the deer, grass, and tiger, I think were the three things, whatever those two things are. And before this function is called, it mentions in the PDF that the positions of these objects are reset before it's called. I'm pretty sure it says. This function determines whether the two objects meet, and it returns a Boolean value back to the simulate function. You need to implement this. It needs to be recursive, and after move function. So you can implement this by adjusting the curve. Yeah, it says it returns it to the starting position. So we can assume they've done the moving and then they're back to where they were. So let's just say, for the sake of example, we have something like this where we have a deer and it starts here. So we'll say this is the deer and its path is going to be left, left, down, down. And then we have a tiger that's going to start right here. Should probably, let me make a grid really quick. Let's say it looks something like this. Okay, that's not great. Looks something like this. We'll say the deer starts here. I guess we'll just use different colors. The deer starts here and the tiger starts here, and the deer's path is going to be left, left. Maybe I want to start it one more to the left here. So left, left, down, down. And then we'll say we have a tiger that goes like this. So this is the initial position, first position, second position, third position, and fourth position. And then with the deer, it goes here, 2, 3, 4. Right, so this will be right, right, up, up. Now what the do they meet function needs to do is it needs to check whether these things match. And the intuition behind this is that we're going to go through each time step, which is not shown in the sample output, but I've drawn here as subscripts. And we need to check if the two objects meet at that specific time step. So time step 0 is going to be denoted by 0. That just means where it begins. And then after they've taken one step into their path, so the deer goes left 1, then it's going to be D1. And when the tiger goes right 1, that's going to be T1. And etc. for as many steps as they've taken. So if this was like D3 and this was T2, then that's not a meeting because they don't meet at the same time step. They're not in the same place at the same time. So what we need to do is check that. And you'll need to do it with some exception handling and some extra stuff. So the do they meet function returns a Boolean saying whether or not they've actually met. And then it takes an integer being whatever this time step is. I'll just call it T. Right, so what we need to do is we only need to solve this in terms of one time step because that's the only argument, and we're going to recursively call this. So the goal, again, with recursion is to break it up into smaller problems. The problems here are just going to be, do they meet at this specific time step? And then the next problem is, can we check the next time step and see if that works? So what you'll need to do is check if I'm just going to write pseudocode, if the position is the same, since we know that they're locked at the same time with this T here, if the position is the same, then they meet, which means you got to return true. Otherwise, we need to try and do the next time step. Before we move to the next time step, we should move the object to where it needs to go. So what you'll need to do is you'll need to get the paths of each of these objects. get whatever its movement is at this current time step. So in this case, time step 1 is R for the tiger and L for the deer. At time step 2, it's R for the tiger and L for the deer. And then 3, it's U for the tiger and D for the deer. You'll need to get that specific character, which represents where they're moving, left, right, up, or down, and then use the set current position function to call that with that specific letter, and then update the position that way. And then you'll need to check basically 2 things here. So I think you'll need to check if it goes out of bounds. I think that still matters. So you'll end the function there. And then what was the other thing I was going to say? Oh, you'll need to check if you're actually at the end of the path. So we have 2 base cases. One base case is if they're in the same position, then they're in the same place, so that's true. And the other base case is when we have no moves left. In other words, they've moved entirely and they haven't met, then we know that that's the case where it's false. So you'll have 2 base cases, one where it returns true and one where it returns false, depending on which of the conditions is met. And so the way it wants you to do that, the false condition here, is you're going to use the string.at function, which grabs a character at that position. So if I did string.at 0, it would be that. It would be 1 less than each of these. So string.at of this path, the tiger's path, is R, string.at 0, deer is L, and then 1 for both is R and L, and etc. And if you go out of bounds of that, it's going to throw an exception. So for instance, if I tried to access the 5th element, or I guess the 4th element here, which would be out of bounds, like off to the side here, then it's going to throw an out of range exception. The way that this particular function wants you to do checking and the base case is if that at function throws an out of range, then you know that you're out at the end of the path because there's no more characters left in the path, the string there. So this whole thing should be in a try block, and you'll want to catch the exception, and that will be when you return false, is when that throws. And I think that's it. The only other extra thing here would be you want to do a recursive call. So after you update the position, assuming it didn't fail and go to the catch, then you'll want to do the recursive call and try to execute the next time step. So do they meet? And then we move by 1 step every single time. Okay, so the rest of the stuff will go there. Does that kind of clear it up, or did you have any other questions on this function? Oh, I guess I should note return, since it's value returning. For sure. Did anybody have any other questions about the exam or assignment 8 that you wanted to go over first? Okay, fair enough. So I guess on that note, if we're done going over review stuff, we'll talk about the topic that we brought up before the break, which I think we had like an even amount of votes for app development as well as game development. So I guess we'll kind of just kill 2 birds with 1 stone and talk about both at the same time. I think last time we talked about using Unity for this, so we'll use Unity for now. If we decide we want to do more app development stuff, we'll probably use Xamarin. But if you have Unity, feel free to follow along. The install version I'm going to be using is the 2020.3.21, which I think is the most current version right now, at least on that path. Right, at least I should note, if you're going to do app development like we are here, then you'll notice I have the Android build support, which you can select when you do the install. But if you click on add modules here, you can see all the different build things that you can support. I would suggest Windows just in general, and then Android we're going to do, you could do iOS if you want. I'm just going to do Android because I think that's fair enough. And so in order to create a new project, we just click new. It will bring this up. Now, this depends on how you want your project to be set up. You can change individual things at any given time. This is just kind of like a template. I think I'm just going to do 3D for now, so we can learn some 3D stuff. Let me change this directory to be in here, folder, and we'll just call it CS202 example or something like that. And then Unity will take a little while and it will create the project. It's going to take a while to load some of this stuff, so I guess we'll just talk about general things to know about APIs like this. Actually, one last thing before we talk more about Unity. I did want to mention, nobody actually asked about it, and I was kind of surprised, because this is usually an issue that people seem to encounter, but if you're doing generics and like templates and stuff, and you're doing inheritance, I just had one recommendation, which I forgot to mention. So say I do template class T class EX. And then it does something, we'll just say int X. And then we do another thing here. That's another template class that inherits from it. Say B inherits from EX. Then one suggestion I have, just in general, because the compiler is kind of weird about inheritance with generics, I've noticed. It's super weird about you putting them in CPP files, and it's super weird about you using member variables for whatever reason. If you were to create a function, void foo, that, let's just say, accesses that member variable from up above, or really any member variable, it doesn't even have to be from an inherited or a derived class, or sorry, inherited class. No, I was right the first time. Let's say I marked this as protected, so it's accessible. I recommend, rather than using it as X, for whatever reason it has some issues with that, so I would say either do this X is fine, that should make it work, or whatever the name of the other class is, so in this case ext dot dot colon X. I would say do one of those two things rather than just write the normal X. For some reason the compiler seems to have issues with these. I don't quite know why. I could never really figure it out, and I never got an answer when I asked about it. Nobody's asked about this semester, but this is an issue I know I've had in the past, so I just wanted to bring it up. I had it written down a few weeks ago and I just forgot to mention it. Okay, so how's Unity doing? Is it still going? It's almost done. Okay, it's opening. We're good. We're gonna have to wait a little bit for something else, so I want to just get that done first. Okay, this is what you'll see if you open up Unity. The first thing I'm going to do here, we have access to settings for a specific project. I want to go to project settings, which I think is an edit. We said we're going to do mobile development, I think, so I'm going to switch this over to Android. You can set some things in this here, including like how the controls work and other kinds of stuff about physics, which we'll probably not use, and like the name of the app and all that. I think in hindsight this isn't the one I want. I think it should be build settings. So I'll go to file, build settings, which I recommend you do if you want to build Android as well. And by default it will build it for a desktop application for PC. But I think we want to do Android for this, and this affects the resolution and everything. So I'm going to go out of my way to do this first. And whenever you want to build for a specific thing and have the editor reflect that, you just click on whatever platform and hit switch platform. And it will take quite a while to update everything. So I'm just going to let that run for a bit. And it will take especially a long time if you have a bunch of textures and stuff. So I'm going to let that run, and I'm just going to talk about some general stuff to note about development. With Unity, Unreal, GameMaker, Xamarin, Monogame, pretty much anything that does real-time applications, it doesn't even have to be game related. There's generally some things that every single one of those APIs does for their objects. So when we create class objects or struct objects, either one is fine, then there's basically three parts to each object. There's the creation, there's the lifetime of it, and then I guess I would say is the death or end of it. And every single one of those APIs, or any APIs you can find that does real-time applications where it's going to update gradually, like update your code on a certain time interval, it's going to have these three things. So in Unity, there's two functions for this, and they're separate, but I'm just going to say start for now. There's going to be a function called start. There's going to be a function called update, which is going to get called every frame. And I hope everybody understands what a frame is. If you're familiar with animation, it's the same thing. And then the end, which I don't think Unity has a built-in. It might be just called onDestroy. We'll have to double check. But there are essentially three functions that you have to worry about. This one is for initializing things. And again, the name differs depending on what your application is, but it's something that gets called when you first create an object. It could be a constructor, or it could be a separate function that gets called in the constructor. And then this gets called every frame while active. We can set things to be either active or inactive. If they're inactive, they're just not going to execute any code. Frame, and then this one should be self-explanatory. This one is when it's destroyed. So if you want to clear anything up. If you're doing C++, this would be similar to a destructor, or might just be a destructor where you want to go and deallocate things. In C#, we don't have to do any deleting, but you might want to set some values or something if something is destroyed. So just something to consider is that these three things exist in general in almost any of these applications. I think this is done now. So we'll go ahead and start setting things up. I'm going to, first things first, open the project in Visual Studio. That's not the right one. So we see we have the example programs thing here. CS202 example. You'll see that if you create a Unity project, it will create a Visual Studio thing for you. If you don't have Visual Studio, you can edit all of this code in whatever other IDE you have. But I recommend having Visual Studio installed because it does support the Unity libraries and it makes it a lot easier. So I'm going to do all my editing in Visual Studio. It creates a project automatically for me, which I'll open here. It should take a second. And that's basically where we'll do all the code. Now, when you're doing applications in Unity, everything is an object, kind of like how we've done with object-oriented programming, and it has code that occurs every single frame, like we said in that life cycle sort of thing. So if I wanted to create something that was an object, all I have to do is go over here and right-click, and I suppose none of these are probably what we want, right? I guess we can make a 3D object. So I'm just going to make a 3D object. You can create any sort of thing that fits into one of these categories. But generally, when you're doing games, you want something that could be rendered to the screen, which is either going to be a sprite, which is a 2D texture, like just a graphic that exists, or you have a 3D object, which is a mesh, or just some sort of geometric solid. In this case, I guess we'll just do a sphere, which is a geometric solid. And it will give you like this 3D thing. So we have this here, it's just a sphere. This is an object in the same way that we've done objects in C++ so far. right? So it has a constructor, it has a destructor, it has methods. I guess from this point onwards, I'm going to call functions methods because that's the way C# calls them. So it has all that stuff. It can have member variables, and it's just a sphere. And we can make it has a relationship where it has all of these components, and when you do APIs like this, you can add components to it. So the sphere by default comes with some things that are components already. Pretty much everything in Unity has a transform component, and when I say component, this is just some other class that exists that it attaches to this object. It's the has a relationship. That's just a Unity thing, they just call it components. Here, it has a transform component, which you'll see has just some specific fields. It has the position of the object in 3D space. It has the rotation of the object relative to this XYZ axis, and then it has the scale. So we can change this and like double it in the X direction. You see it's kind of like an egg now. Or we can make it 2 in all 3 directions, and now it's just a sphere that's 2 times as big. Right? We can make these all decimals as well. That'd be fine. So we have all this stuff. We could also rotate it in some certain direction. So I could do 90. You see, it doesn't really do much around the X-axis, and 90 this way, and it just kind of turns it. So you can kind of adjust these, and we'll address them in our code. I'm just going to leave this as a sphere, but just so you're aware that those exist, we have those. And then we have the mesh. We have the mesh renderer and the mesh filter. I think the mesh filter is just for setting it up. Mesh renderer just has to do with displaying the thing. When you have 3D objects, for those of you who aren't familiar, you have something called a mesh, which is just like the set of the outside, kind of like if you put wrapping paper on something, the mesh is the outside of the thing, and that's what gets rendered to the screen. So with a sphere, that's just like the ball shape here, but if we had like a person, then there'd be a lot of triangles and quadrilaterals that make up the person's face, and that kind of structure is the mesh. It's just the thing that represents it. And the mesh has its own things, some materials, some lighting. These are mostly things for 3D artists, which we won't worry too much about. And then it threw a sphere collider on top of this. A sphere collider, or just a collider in general, is going to be a 3D hitbox, if you're familiar with those. Basically just tells you where this thing is in terms of like physical space, like the space that it occupies. One thing about game design that I guess also applies to just general app development is that the graphics are separate from the functionality. So the mesh renderer deals with the rendering of the sphere collider deals with the actual like space that it occupies as far as the game's concerned. And you'll notice here that it has a center and a radius and stuff like that. I could, in theory, make this bigger. You'll see that now we have this big green sphere that's bigger than the actual sphere. If I do that, then what this means is that the visual representation of this sphere is just the little white part, the actual mesh that represents visually what this object is supposed to represent. The sphere collider is how it interacts with other objects in the game. So the physical part, like the coding part, is separate from the visual part. And I don't think that makes a whole lot of sense here, so I'm just going to move that off. But in certain cases, you may want to do that. Especially if you have something complicated like a human being, you don't want to do some crazy mesh collider that looks like a human being. You probably just want to do a sphere collider. In that case, they wouldn't match up. But just know that spheres and boxes are very quick to compute, so you generally want to try to use those, which we're going to do here. Last thing to mention about this one is it has an isTrigger thing, which basically just tells it whether or not to do it with the physics system. If it's not an isTrigger, then it's going to be part of the physics system. If you do it as an isTrigger, then it has no like collision, which I guess we'll talk about collision in a second. And then the last major thing that everything is going to have, at least if it's a 3D object, is a material. And I won't go into a whole lot of detail about this, but it's basically just how it decides to render it. By default, it's just white. But if we wanted to create some materials, I'm going to go ahead and create a folder here, just called materials. Then we can create kind of just a simple material by going to create material, and we'll just call it sample, I guess. And a material just tells it how to render things on that mesh that we have. So again, a mesh is just like a 2D wrapping paper kind of thing. This material tells it what colors it is, how the lighting interacts with it, and some other stuff that we can apply. So the albedo is just like the default rendering color. Here it's just white. So if I made this red, you'll see that the material becomes red. So it renders it as red instead, kind of just the basic color. The metallic slider tells it how to bounce light, or I guess absorb light, and the smoothness also tells it how to kind of diffuse light. So notice if I move it up, it gets kind of shiny, and if I move it down, it gets kind of matte. I guess we make something shiny here. And then there's all this other stuff that I can't really do without making some extra stuff, which are normals and height maps and occlusion and stuff. I will explain normal maps if you're curious about that, because those are pretty common, but everything else we'll just kind of say, oh, that's fine. You can also do some tiling. If you have a pattern, you can repeat it. And if you wanted to bring in a texture where this is not just a plain color and you wanted it to represent something, then you could drag that in too. Maybe we'll come back to that later, but we'll just create a simple material. Now what we want to do is either drag it onto the thing in the thing over here, the editor hierarchy. This is going to show you all the objects that exist in your scene. So a scene is just like a specific room or one specific set of objects that you have in Unity and a lot of other things. And it contains all of these objects that are going to be within the scene that are going to interact with each other. So we have the sphere that we've created. We have a light that's just simple. And then we have a camera, which is just going to be the thing that looks at all the things in the scene. We totally have multiple cameras. I'm just going to stick with one for now. But what you want to do is you either want to drag the material onto whatever the object is, or drag it over here. You can drag it directly into the 3D editor window and it will let you put it straight on the object. Or you can select the thing. So I'll select the sphere here. You can see all of its components. And we can go over to the material component and we should be able to drag it, but it doesn't seem to like it. I don't know why. So I guess we'll just drag it there and you'll see it replaces it. You can also set the shader, which we'll maybe talk about if we have time. I'm just going to leave it with the standard for now, which just, that's kind of how it defines how the lighting works, is what a shader is. So this is our first object. We have something just in 3D space. Let's go ahead and make this ball just bounce, I guess. Probably a good idea. So let's create a floor for it to go onto. We'll create another 3D object. In this case, we'll do not a sphere. We'll do a 3D object. We will do a cube. Just call this the floor. And then I'm going to center it and move it downwards, just maybe -2 or something like that. And then, I don't know, we'll make it kind of flatter and then extend it in the other direction. So maybe 4 this way and 4 that way. And you'll see now we have this, this sphere above that box. Now, unfortunately, the WebEx thing is in front of the play button, so I'm going to have to move this a little bit. If I hit play, what we should see happen is they should just do nothing. So nothing interesting is happening yet, you'll notice. And we haven't really told it to do anything. So we're either going to need to introduce some code that makes this, fall, because the ball is just kind of floating there, or we're going to have to add something pre-built from Unity in order to fix that. So let me move around a little bit. Let's try to add some physics to this thing. If you want to add physics in 3D, you can go to Add Component. If you go to Add Component in general, it's going to have this whole list of pre-built things or code that you've written yourself. For now, we're just going to use the pre-built Unity stuff. If I go to Physics, and then we have colliders, which are the hitboxes that we've seen here. They determine where the thing occupies. There should be a rigid body. So there's a rigid body, and then there's a rigid body 2D. One is for 3D applications, one for 2D. The rigid body is for 3D, so we'll use that. I'm just going to use the default stuff, but once you introduce a rigid body to an object in Unity, then it should fall. It starts obeying the physics system that exists already in Unity. These APIs like Unity and Unreal and pretty much anything else that does real-time stuff like this will probably just have their own physics system, and yeah, it will simulate everything for you. Might not be what you're looking for whatever specific application you're doing, but if you just want to make something quick and easy, then there you go. So now it at least obeys some physics laws. It falls. There's gravity. It didn't fall through the other thing, I guess we should mention. And the reason it didn't fall through the other thing is because they both have colliders. If you'll notice here, if I tick off this collider on the floor and then rerun it, we should see that this ball will just fall straight through the floor. Yeah, right? So that, I guess, hopefully clears up my explanation of what a collider is. It tells it where the object is, and the graphics are separate from that thing. So if I tick off a collider, there's no collision, they just fall straight through each other. Maybe we should at least try to make this do something more interesting than just fall. We can try to make it maybe bounce. There's some things here that we can check. I don't think we particularly need any of these. The mass kind of just deals with how heavy it is with respect to other things. If they like collide, like if you have something that's really massive and something that's not, the really massive thing is gonna like overpower it. I'm assuming everybody has like a baseline understanding of like high school physics. Drag just tells it how it is affected by air. So the higher the drag, the kind of slower it goes through the air. The angular drag is related to that, I believe. You can see, check use gravity if you want it to actually fall, like we have there. Is kinematic, I forget what that does, but it is usually important. Interpolate, you usually want off. Collision detection is just how you want to have them check that they're actually touching each other. Generally, discrete is faster, continuous is more accurate. For the sake of our thing, we're just going to use discrete. There should be another thing for material, I thought. Oh, there it is. It's on the collider. So there's two types of materials. There's the material for the mesh, which is the way that the thing looks. And then Unity has its own thing that it calls a material, which is not like a standard thing across everything. So whereas the material for the graphics, that's something everybody uses that term. The material here is like a physics material, so I'm going to create a separate folder for that. And it just represents like how things are going to interact with each other in the physics system that Unity has built in. I'll call this physics material. Right, so we'll create a physics material. Let's call it bouncy, I guess. And it has a few things. It has friction, which I'll assume everybody knows what friction is, and then bounciness, which determines how much of its velocity when it hits the ground it's going to preserve. So if I make this something like 1.4, we should see that it will bounce pretty high. So I'm just going to go ahead and drag that onto the red ball. I think it took it. And we should see now if I apply this physics thing to it, bounce a little bit. Still not great. Let me move the camera a little bit closer as well. One other thing, you don't have to go straight over to these and affect the numbers. You can actually just drag it using the arrows in the 3D space. So I'm just going to move the camera a little bit closer just so we can kind of see it better. I think what we want to do is do bounce, combine, multiply. I think that'll let me make it bigger than 1, right? No? That is not working how I thought it would. I wonder if bounciness, the smaller it is, the more it bounces. No? Apparently I don't remember how this works. So let's kind of leave it. Oh well. I guess this is bouncy as we're going to get. I'm sure we could play around with it more. But as long as you understand the physics stuff that we have here. So physics materials affect how this thing moves in the physics system with its friction and its bounciness. And then we have the graphics material there. Okay, so let's say we actually want to add some code to this. We're not just going to use all the built-in stuff that Unity has. Then we have the ability to do that with scripts. Let me create another folder here called scripts. And scripts are where we actually write the code that affects objects. Now you can tie these to objects themselves, like things that are in the game, or you can make them static and just have them manage things. So for example, if you wanted to have something that manages UI in your game or manages saves or stuff like that, or does the same thing for any sort of application where it saves user data like settings, or does a login, and just handles the way that the user is interacting with things, but it shouldn't be like an object that they see, then you maybe want to make that thing static, and you can do that with just a script here. Now I'm going to go ahead and just create a script. Just go to create again. C# script is what we're going to do. And I guess what we'll do is we'll just add some controls for the sphere. So we'll be able to move it around a little bit. So we'll just call this, I guess, sphere controller. And you can separate. The nice thing about this, and really any big coding project you'll find as you do this more and more, is that you can separate all your code to just be a couple functions or methods and have them be separate and then attach them all to the same object. So first things first, I'm going to take this sphere controller, I'm going to attach it to the sphere. You'll notice it gets populated over here. We could put other pieces of code on top of that. And the nice thing about this is it allows us to reuse it for as many objects in the game as we want. And I'll have this sphere that has a controller. In order to edit it, you can either double click it here, or we could have right clicked on that component and selected edit. If I double click it, it should open it in Visual Studio after some time. And you'll see that it generates some stuff for us in advance. When you create a script in Unity, it's going to give you two methods by default. It's going to give you the start, which is called when the object is first created, and then it's going to have the update method, which is the method that gets called every single frame. And you'll notice it inherits from a script that already exists that Unity has called MonoBehavior. If you want any object to be in the game and interactable, you generally want to have it inherit from MonoBehavior, but if you want to have one of those static classes that I mentioned earlier that does just saving or just general managing of some things behind the scenes, then you probably want those to not inherit from it so it doesn't do anything extra. Now, C#, for those of you who are unfamiliar with it, it's very similar to C++. It simplifies things a lot, and rather than being function-based like C++, it is class-based. What that means is that nothing can be outside of a class. Everything has to be inside a class no matter what. Now there is still a main, but main also has to exist in some class that exists somewhere. Somebody else has written main somewhere else to do all the calling and all that stuff, so we don't have to worry too much about it. But we do have these methods, and they're going to belong to our sphere controller script class. On top of that, there's no include. The word include is gone. It's just using now. So you just specify the namespace that will include all the code from that namespace. So we have these three namespaces that it automatically included that have Unity related code in them. It will just include all that stuff for us by using the keyword. And then the other thing to mention is that by default, the inheritance is public. So you don't have to write the word public every time. It just knows, hey, that's what you want, because public inheritance is usually what you want anyways. Okay, so we have these two functions, or two methods, called start and update. Start is going to be what it does when it's first created. That could be either when the scene starts or when the object is created, if you create it during the course of the game rather than at the very beginning. And update is something that gets called every single frame. And what we wanted to do here was we wanted to be able to move this, so we'll do that every single frame. Let's just check what the user's inputting on their keyboard and then move the object as it goes. So I think we'll do a couple things here. So we'll do kind of like an if check. Yeah, we'll do it with ifs. So if input I thought it was called input manager, but I might be wrong. Let me see if it found the Unity stuff at least. It did not. Real quick, let me close this. Sometimes it's a little bit weird about recognizing like the autocomplete stuff. See if it gets it this time. It's a game object. It's still loading. Okay, there we go. That's game object. One thing to note about Unity is that anything that you put in the game is going to inherit from game object, which is just like a base class it has for everything. But I think the way we do input is with input dot, and then this has a bunch of different methods that we can use. So you can do, there's essentially like key down and then key pressed. So I'm going to do get key. So I guess there's three parts to any sort of key press or button press. There's down, up, and just general thing. Down tells you if it's the first frame that the thing has been down. So if it's like the first point at which somebody pressed the key down, then it will return true. Otherwise, it will turn false. So these are Boolean returning. Key up tells you if it's the first frame that somebody released the key, like they took their hand off of it. And then get key tells you whether it's just down in general, every single frame. For the sake of our thing, we're just going to do the general get key. And then that takes a parameter called a key code, which is just an enumeration type. We'll do key code dot, and then we want to do whatever thing on the keyboard that we want here. So we see that this gives me a whole list of pretty much everything on the keyboard, joystick buttons as well. I think we'll just do WASD, W-A-S-D. So if the person has W pressed down, then we'll do some code. Else if this. One thing I should mention while we're typing all this stuff out, in C#, you don't have any of this stuff, or this thing. None of that exists. It's just arrow and the scope resolution operator. It's just dots. Everything is dots. Which I think is kind of nice because it makes you not have to remember what type everything is and then do them differently and all that. You can really just do everything with a dot. So enumerations, methods, any kind of member, they're all going to be dots. One other thing, there's no pointers, kind of. Everything is a pointer, as long as it's not a primitive type, like an integer, or a Boolean, or a character. Everything is just going to be a pointer, which is why it doesn't need to have that arrow thing. It just assumes everything's like that anyways, and there's not really a reason to make a distinction. And because of that, it actually, if you do any sort of method calls, everything is by value reference, which we talked about a little bit before, unless you specify some specific like keywords. Yeah, so it yeah, everything's by reference in this language, and everything's done with pointers. But you don't have to know all the crazy pointer stuff. It's just, it handles it for you, which is super nice. It's kind of why I like this language. But anyways, we have all this written out. So if the user is pressing WASD. Now, what we'll do is we're going to apply this to the object that we have. When you write a script and it's attached to an object, you can get other components that are attached to that object. It's going to take a while to compile there. The sphere had the sphere collider, which was the hitbox, and then it had the rigid body, which we said earlier is the stuff that does the physics. We need to get that rigid body so that we can figure out, well, physics stuff, and we can also call methods that exists for that physics thing. So what I'm going to do here is I'm going to do a get component. There's a function or a method called getComponent that grabs any component attached to the same one as this script. And then you'll see it takes a generic type called T. You just specify what type of object you want, and that's how it does the lookup. If you have multiple of that component, it'll just grab the first one. So here I'm just going to do getComponent rigid body. And that should grab the rigid body. call it R body equals that. And then we'll take that rigid body and we'll do one of its physics things here. So you see we have like add force, add relative torque, just a bunch of different things. I think move position is probably a pretty good one. I think move force is the standard way to do it, at least if we want it to be realistic. So we'll do add force. And then add force takes either a vector 3, or I think you can do 3 doubles as well, 3 floats. So there's 2 ways to do this. We can either do it with a vector, which, let me just explain this. This is like your traditional math vector, which means it's just something that has components like numbers in this case, and it has that many things. There are built-in ones up to 6, I think, so there's vector 2, vector 3, vector 4. Vector 2 is probably just called position, but these things that are just collections of numbers. A vector 3 in the context of the rigid body is going to represent x component, a y component, and a z component. In our 3D space, if we look in the editor, then this blue axis, that's the z direction. This red one, that's the x direction, and y is straight up and down. So in 3D space, there's like 3 components, right? Length, width, and height. So if you do that here, the vector 3, the first number is x, the second number is y, the third number is z. So we could either create a new vector that has those 3 numbers, which I'll probably do in a second, or it also allows you to do 3 numbers, which the first number is how much you want to move in the x direction, how much you want to move in the y direction, and how much you want to move in the z direction. In this case, it's force, so it's like applying it, which means it's going to be preserved and all that. So my ball is probably going to roll off the side here, but let's just say when we do W, if we look at this relative to the camera, so the camera's over here. Let's kind of get in place of where the camera is. Then you'll notice that forward, like away from us, is in the z direction, which we can't see right now, but if we kind of rotate it, you'll see the blue direction is z. So forward is z, and then backwards is also z. So if I want to move forward, we want to move 0 in the x direction, 0 in the y direction, and positive 1 in the z direction is away from the camera as far as our setup right now. Let's just see that in action really quick. We'll let it compile. And run. Okay, so we have this ball here, and if I hit W on the keyboard, you'll see it slowly rolls until it falls off, and it's gone. We can never see it again. Maybe first things first, let's make this a little bit bigger. Put 20 here, 20 here. Looks a little bit nicer. Maybe add a temporary texture to this as well. I don't think we can make a nice one. Let's just go make another material so that the floor is not white. Oh, whoops, I made a physics material instead of an actual material. Create material, we'll just call this floor. And then, you know, let's make the floor have one of the built-in textures. Let's just make it look like this. So I'm going to drag this onto the floor. And then maybe tile it a little bit. Oh, or, I'm sorry, that's a secondary map. Let me just make it kind of like checkerboarded. So this is, I guess, an example of a texture. You can import images. I guess that's a simplification, but you can import things that represent not just flat colors, which are called textures. They represent like how the thing looks with an actual image that maps to the mesh. So in this case, I'm just going to use the default Unity one, which is this checkerboard thing. And then you can modify other things here. You can still modify the color, like how it's drawn. So we could make it like yellow or something. I think these all kind of look gross. Green looks fine. Something like that. That looks okay. Maybe turn down the metallic and make it matte. Cool. So maybe this looks a little nicer. And then we have the ball can go a little bit further. Although I haven't programmed it to turn around, so it just kind of keeps going. Right, so that's our basic setup. So we could keep going. We could do this rigid body for A, S, and D, which we'll finish here in a second. But let's go back up to the top and change some things about this. So one thing about this is particularly bad that I've done so far, and something you should never do. So we said update gets called like every frame, right? It's something that is going to happen over and over again. And because of that, we want to avoid doing anything that takes a really long time, something that's computationally expensive, or at least more expensive than it should be, every single frame if we can help it. And we have this function called getComponent here, which you can imagine does some sort of lookup in the list of components that we have in that editor, and then grabs it and gives it back to us. And so every frame we're doing that, we're going and looking this up. But the rigid body for this object, the thing that controls the physics, should never really change. And so us doing this every single frame is probably a bad idea, not a great idea. Let's avoid doing that. In order to avoid doing that, we're going to make it a member variable. I'm going to do a rigid body r_body up here. And then rather than get it every single frame, this is an example of where the start function or start method comes into play. Let's just grab that rigid body, the thing that controls the physics, one time when this is created, and then just reuse it for the rest of the duration of the thing. Well, now we're not going to see any performance hit because it's not like we have a ridiculous amount of code right now, but a very good idea not to grab something every single frame. And then let's just finish the rest of this code here so that this moves in the other directions as well. Okay, so W is forward. We want S to be backwards, so that'll be -1 in the Z direction. A is going to be left, which was the X component, so we'll want the X component to go -1. And then for D, we'll want the X component to go 1 and the Z component to go 0. Hopefully everybody can kind of visualize that. I think I actually have the A, S, and D, or sorry, the A and D backwards. Let me modify that really quick. In this case, where the camera is, I think 1 is to the left and -1 is to the right. Okay. So if we compile it again, we can still move forward. Now we can move in opposite directions. And I think my controls are actually still reversed. But now we can kind of like fully control our ball, which is cool, right? We do this physics stuff and make it work. Change these back really quick. This was right. All right. Any questions on why this works? First off, is everybody okay with the 3D space stuff? Okay, sounds good. Okay, so let's polish this up a little bit, maybe. Just go over some other basic stuff that we can do with 3D stuff or 3D projects. So I think one thing would be, let's make the camera not where it is. Let me run this one more time just so I can show what I'm talking about. So you can imagine if you've played games before, then this probably looks kind of jank, right? Is this ball is moving, but the camera's not really following it. And I could even like go behind the camera and then come back. And it's not great to look at. So we probably want this camera to follow the sphere. if we want to do that the simple way, then I think we'll just do that for now. What we're going to do is we are going to just attach the camera to the sphere. Drag and drop it. If you attach something in Unity, then they're all going to move in exactly the same way. Anything that is a child of an object is going to follow anything its parent does. So here, if I just do that one simple step, we should see that the camera is at least a little bit better, if not great. So we're going to need to program it a little bit. You'll notice that because it follows all of the physics, then it rolls along with the ball, which is kind of nauseating. Let's turn that off. So we probably don't want to do it exactly that way. Instead, let's make the camera follow the sphere, but let's not make it that awful. So we could just make it attached to it and then kind of correct it every frame and make it not do that stuff. But I think we're just going to have it be separate and then focus on the player. I'm going to do this in a bit of a strange way. I would normally implement this different, but we're doing something kind of small here. But I am going to create a script. I guess I should go over here, add components, and then we'll go to new script, and we'll just call it the camera controller. And then I'm going to move this over to the scripts folder really quick. I'll open it up. What we wanted to do is we wanted to follow the player every single frame, and we probably also wanted to kind of track the player a little bit. I think we'll do both of those things. Now, the way we could do this, we could do what we were doing earlier and be kind of naive about it and grab the player every single frame and do like a lookup. One thing to mention, I try not to use it. I suggest not using it unless you can help it. There are these tags and layer things. You can give an object either a tag or a name and then do a lookup on it. I think it's something like game object dot find, and then you would provide the name of the object. So here that would be called sphere, and we could grab that every single frame. It's not the best way to do it, and if we are going to do it that way, we should again do it only in the start. We should not do it in the update every single frame because that's slow. And what I'm going to do is I'm just going to give a static reference called player. We'll say player ref. Basically, we're just going to look up the player one time and then keep track of them the whole time. And the reason I say this is kind of weird, and I would implement this differently if I was doing this in an actual project, is I wouldn't tie this to the camera or like everything that refers to the player. I would probably create one static manager class that keeps track of the player because they're so important and just finds them one time at the very beginning of the game, or at least at the beginning of the scenes, and then everybody else goes and looks at that thing. But for the sake of this, let's just create a static reference. So static meaning it's going to be just shared amongst all instances of this class. All cameras will only know of one player. And let's do a lookup. So we could either do a lookup this way. We say, hey, go find the sphere. I'm going to recommend against doing this, but let's just make sure it works first. And then what we want to do is we want to kind of follow the player from a distance. So last time you noticed it rotated around it, which was kind of annoying. And then the position was also a little bit low at the beginning, so it was kind of like eye level with it, which is weird. Usually you want to view things from kind of like a top perspective, kind of looking down. So let's just start with something very basic. Let's do another thing. So I'm going to create a static. There's a word in C# called read only, which is the equivalent of constant for things that aren't primitives, so things that aren't integers or floats. Read only means that it isn't modifiable. I'm just going to do something called read only here. And I'm going to create a vector 3, which is going to represent the position XYZ that the camera is going to be away from the player, called offset. So if we kind of view the player here, I think we want to be a little bit away from them and on top of them. So probably 1 in the y component and maybe -1 in the z component, and then level with x, maybe. So I'm going to do equals a new vector 3. One other thing about C#, you always use the new keyword when you're calling a constructor. So not just the word vector 3, it always has to have new in front of it, is how you specify this. I'm going to make an offset, which is just how far we're going to keep the camera away from the ball so that we can kind of see it well. Maybe something like, what did we say? The y component, maybe 1, and then the z component, maybe -1. And then every single frame, I'm going to update the camera's position so that it's that far away from the player. So we have that transform component we talked about earlier that contains the position. And we're going to say that that's equal to the player ref. We're going to get the player's position every single frame. And then we're going to set our position to be the player's position plus this offset of like how far we want to keep the camera back. So now, assuming it lets me go back, we run it, and maybe my offset's not great, but you'll notice it does follow it at least. And it kind of remains eye level with it, but we can now follow along with the ball, and at least we're on the right side. So maybe I should make this a little bit further away. Maybe make that a -4. Let it compile. Let's take a little while. Oh. Now at least a little bit further back. I think I still need to move it a tad bit more. But yeah, so here we go. We can see the player, and now we can kind of like follow it along with the camera by updating our position every time to be some amount of distance away from the player every single frame. But you notice it was still kind of weird, like it was chopped off even though we are kind of far away. So last 2 things, let's just do 2 more things before we finish up. Let's try to make it so that we're actually looking at the player and not at that weird angle where it kind of gets cut off. Let's tilt our head downwards, so to speak. So the camera's looking straight ahead right now, which means it's looking over top of the ball, but we probably want it to look directly at the ball. We can do that here. And we're going to do an update. We're going to do it every single frame. We can take an object's transform, and we can do a look at method. And what look at does is it, you know, if you can imagine just like your eyeballs looking directly at the thing, it's going to make it point towards that thing. And then you tell it where it needs to look at. And this is going to look at the player ref's transform. And we should notice that it does look at least a little bit nicer if we do that really quick. And now you'll see, without changing the offset, this looks way better than what we had before, right? Now it's not looking over top of the ball, it's looking directly at it. Cool. So that's what the look at method does. It just points it directly at an object using its forward vector, which we can talk about maybe more next class. And then the last thing I want to do is just clean this up really quick, and then we'll call it a day. So I said earlier that you generally don't want to use this find method. It goes and it looks up a string. If you remember, string lookups and comparisons are just generally pretty slow. So I would recommend not doing this if you can help it. What I'm going to do instead, I'm going to delete that entirely, get rid of it in the start method. And what we can actually do is set it in the editor. There's 2 ways to do this. You can either mark it as public. One other thing about C#, you don't just put public or private and then a modifier and then everything underneath it is that modifier. You put it before every single variable or method in C#. So if I wanted to mark everything as public, I have to put it on every single specific thing. So I'm going to make this either public, or another way to do it is with the serialized field. I think that needs to come first. I'm kind of forgetting the syntax off the top of my head. I think it's first, yeah. if you put serialized field in these brackets, it will also keep it private, but you'll see here that it lets us use it in the editor. So if I go back over here and let the editor reload some things, then you'll see on camera controller scripts, I can't have it be static, unfortunately. That is, I guess, the one issue with the serialized field thing. You can't have it be static for some reason, it doesn't recognize it. But if I make it non-static and I do that serialized field thing, you'll see here it just fills in this player ref thing and says the type of the variable that I created. And now we can set this without having to do anything extra. So I can literally just go and drag and drop this sphere and put it over there, and now it knows that the sphere is what that variable was. If I go and run the code again, it should just work exactly like we had earlier. But you'll see I didn't have to do the lookup anymore. I didn't have to do any sort of thing in the start method. I can just set it in the editor by dragging and dropping, and that's faster, so I recommend you do it. The one problem here being that it's non-static. So I probably wouldn't do this way with the player, but if you have things that you're going to commonly use, then it's a good idea to use the serialized field or make it public and just get a reference to it that way. Okay, so I think we're at time. We'll call it a day here. I think we'll talk a little bit more about this next class. Since we did talk about mobile applications, we'll maybe talk about some UI and then exporting it to at least Android and testing it. If you have any questions, I'll stick around for a little bit. Or if there's any other topics that you want to talk about, feel free to bring them up. I think there's one other computer science related topic that we'll discuss before the end of the semester.